So in this part, we're going to take our character, which can already technically move around the screen, and add 4 directional animations to it. So we want our character to be able to do all of its animations in up, left, right, and down motion. So we'll start with idle and walk, and later we'll add in swing animations as well. So before we get started with that, I want to do a couple things with our scene. First off, I want to grab the main camera and change the background color. So if you select main camera from your scene hierarchy and go to environment and the inspector, you'll have background type. If it's set to skybox, change that to solid color. And let's change the default background color to something nicer than that default blue. So I like to go with something like a dark gray as the default background. So the other thing I want to change is that when we enter play mode, you'll notice that it tries to reload and complete the domain. This is part of making it so that when you play the game in the editor, it should perform exactly like it would in an actual build of the game where you have it published and everything. But when we're working in the editor, generally speaking, we just need to kind of test and make sure that the code we wrote is working. So we can save some time entering play mode by enabling play mode options. To do that, we can go to Edit, Project Settings, go to the Editor tab, scroll down to the bottom, and we can enable play mode options. So there's Reload Domain and Reload Scene. Reload Domain is the part that takes the majority of the time. So a lot of times I'll just have Reload Scene enabled just cause. But you could have them both turned off if you want it to be as fast as possible. So with just Reload Domain turned off here, we can hit play, and you can see we enter play mode almost immediately, since it doesn't need to spend the time reloading the domain every time we hit play. Okay, now that those two things are out of the way, let's actually focus on the animation for our character. So if we go to the characters folder, we have the character here. And if you haven't already, you're going to want to add a animator component to the character. So I think I might have done that off screen, so I'll just remove that real quick. We double click into the gatherer prefab, go down to where we have add component, add the component animator, and that'll be inside here. So as I may have mentioned at the beginning of this series, the way that I'm going to be setting up animations is that we want to be able to attach a tool to the player and have the tools transform, move around as our character animates. So if we did this the traditional Unity way of going into the animator window and setting up a bunch of blend trees in here, what would happen is that it would take the transform positions we set on each keyframe and try to blend them halfway in between as we're moving from, say, the walk right state to the walk down state, which means that the position of the tool isn't going to be set up correctly. So to get around that, we just skip blend states entirely. Now, there is a plugin online that is pretty good for handling this kind of thing. It's called Animator, but I'm not going to use that in this project, simply because I don't want to force you guys to have to use an external plugin. And when I provide all of the code at the end as part of the patron itch.io package, I don't want to force you to have to, once again, download an entire plugin just for the simple setup we're going to be doing here. So instead, we'll just write our own code. It'll be relatively simple, and we just need to make sure that the player is facing the right direction, depending on what our player input is that we're getting from the input system, from player input, as we did in the last video. So anyway, enough about that. We're going to be setting up a animator controller, but we're not going to create any links between all the animations. The animation switch and code will be done in our scripts. But in order to easily set up the clips on our character, I'm going to be creating a animator controller. So I'm going to right click, create animator controller. I'll call this AC gatherer, and then we can click on the gatherer prefab, go down to the bottom where we have runtime animator controller none, and drag in the gatherer AC. So when you have that set up, you can click on the gatherer character and go over to the animation window. And now you'll have the option here of creating animation clips. So you can find the animation window by going to Window, Animation, Animation here, and then just dock it in whichever part of the screen you want it to be in. And so we'll be needing to create our animation clips inside of the gatherer folder. So I'm going to hit create clip, and let's go ahead and add in our animation. So I'll call this clip gatherer idle right and hit save. So for the samples, I want to take this down to 5, which gives us 5 keyframes in a single setting to change and manipulate our character. We're only going to be actually setting a idle frame right here at the start. Okay, so to set up this gatherer right animation, we just need to go into the art Gatherer's exterior characters folder, and we're going to grab the walk right frame 0, and I'm just going to drag this in here for the character. I think it's not letting me because we have to have the character selected. Okay, so character selected in the hierarchy, drag the frame into the animation window and let go, and then gather a sprite will be a property, and our frame of animation is right here. So you could hit play and you could see that it will just keep looping through whatever frames we have set here, but there's only one, so it's just going to be the character kind of just standing there. So let's create idle up, down, and left as well. So I'll just create a new clip and I'll call it gatherer idle down. Let's find the down walk animation, expand it, and get the 0 frame, and just drag that in here. And also set the samples to 5, just for consistency. Make sure, the important part, that the sprite frame is set to frame 0 here, so 0 seconds, 0 frames. And we can go ahead and do this a couple more times. So gatherer idle up, samples to 5, find the animation frame, expand it, drag it in here, and then we need gatherer idle left. So gatherer idle left, hit enter, 5 samples, and let's grab the animation frame and just drag that in there. Okay, so we'll work on the other animations a little bit later. Let's just start by getting the directions to work on our character. So if we go to our characters gatherer folder where we have the prefab, you'll see these 4 animations. So what I want to do is combine these into a scriptable object where you can have up, down, left, right animation clips stored in one scriptable object. And the scriptable object would also be able to tell you what animation you should be playing based on directional input from the player. So this is going to mean we need to write a new script. So I'm going to go to the assets folder, and we're going to create a script folder, and I'm going to move the PlayerController script into here. So let's right click and do create folder scripts, and I'll drag PlayerController in here. So any new scripts are just going to go in the scripts folder. So, after the domain reloads, give it a second. So now entering the scripts folder, let's right click, create a new C# script, and I am going to call this directional animation set. I think that should work pretty good. And you'll see in the inspector that Unity will go ahead and default this to a model behavior, but we're actually going to change that class type to a scriptable object. Let's go ahead and double click to open up the directional animation set. And then let's change the class it inherits to scriptable object. So a scriptable object is different from a model behavior because a scriptable object, when you create an instance of it, it rests in your assets folder. They don't exist in the scene, which means they don't get removed from the scene. And you can use a scriptable object kind of like a mini database, something that you can reference for data wherever you need it across your game. So it's great for things like items, where you want to know stuff like the item value or what the item name is, stuff that never really changes, but you might need in your actual game objects in your scene. So like a character that exists in your scene might have an instance of a item, but that doesn't mean that it needs to be constantly updating what that item is or the details inside of it. So for that kind of stuff, a scriptable object works really well. However, to create a scriptable object, you don't attach it like a model behavior script. Instead, you would want to do create asset menu up here at the top. And generally with that, you want to specify a file name. So I will call this the same file name as the class name as default. So directional animation set, I'll just copy paste that in there. And then you want menu name, which is the path to find it when you right click and you go into the create menu. So we want, let's use the name of our project here, gatherer top down RPG, and then the final path to the exact link in the menu will just be the directional animation set. So when we're right clicking, going into the menu, we're looking for gatherer top down RPG and then directional animation set. When we click on that link in the menu, it's going to create an asset in the folder we're currently located in our project viewing window. So things to know about scriptable object. First off, it doesn't have a start and update method. It's not an object that exists inside of your scene, so you can't use it like that. Okay, but what the scriptable objects are good for is storing data that is going to be consistent in your project. So for instance, that could be animation clips that you're using for your character. So we're going to create 4 properties here for the animation clips. So let's go ahead and add a automatic backing field to our property, so we can set it in the inspector. So field, serialize field, and then we want a public animation clip. So that's what we were just creating, the idle up, left, right, down. And we want one for up, get private set so we can't change it from other scripts. And I'm just going to copy and paste this 4 times, or 3 more times rather, so that we can get the other directions. So we want one for down, we want one for right, and we want one for up, down, left, right. Okay, so we need left. The order here can be whatever you want it to be. Okay, so we can go ahead and create this scriptable object, and we'll add a little bit more code later so that our scriptable objects can tell us which clip we should be showing. But for right now, we can at least see it in the inspector. So let's go to Unity, and we want to have a place to store our scriptable objects. So I guess for us, since it's still tied to the character, let's jump into the gatherer character, and we'll just put them in here for now. So I'll right-click, go to Create, and at the top here, we'll have our new menu, Gatherer Top-Down RPG, Directional Animation Set. So as you can see, this scriptable object has 4 fields that we can set, up, down, left, right, clip, animations. And then we can use that wherever we reference the scriptable object, or the scriptable object can take that information and have its own functions as well. So instead of calling it directional animation set, I'll call it directional animation set underscore idle. Yeah, I guess just underscore idle. So let's assign down, left, right, and up to their fields here as we would expect. So gatherer up goes to up, down goes to down, left goes to left, and right goes to right. And you know what? I'm going to swap right and left here. Up, down, left, right sounds better than up, down, right, left to me. So I'm just going to go into the editor, and let's just move the positions here. So they have the same naming and everything. So doing this shouldn't unset anything in the inspector, but it should change their positioning. So let's click on set idle, and now we can see up, down, left, right. So where are we going to use this animation set? Well, that would be in our player script. So let's go into scripts, PlayerController. And then up here at the top, let's add a field to set that animation set. So we'll have field, serialize field, public. Let's see, directional animation set, and that is going to be idle. Get private set, so that we can only change this in the inspector or inside of the script. And then we can go back out and click on gatherer. And then we can see the field for our animation set. So if we click on this little button over here, it'll look through our project for any directional animation set scriptable objects, and we can set the one that is relevant here. So I'm going to click here for that. And it does occur to me that other characters might have a idle directional animation set. So I'm going to go ahead, go back to the characters folder, and I'm going to rename this. I'll just call it gatherer idle. I think that's specific enough because it's clearly a scriptable object, not an animation clip. So it shouldn't be a problem naming wise. Okay, but now we have this set for our player controller. So our player controller knows what the idle clips are going to be, and we just need to have it set the right one. So to do that, we need to feed some kind of facing direction into the animation set that is our current set, and then we play the animation clip from that using the animator component. So since we need the animator component, we're going to need the animator. So let's get that, private animator underscore animator, and then we'll get that down here with animator equals get component animator, just making sure we have it referenced at start. We're also going to want to know what our current animation set is. So I'll just do a private directional animation set, current animation set, or we could just say current set. At the start, we'll just set this to idle. So let's do current set equals idle inside of start. And then whenever we're updating our character, we want to make sure that it's playing the correct animation. So we can have a update method. This doesn't need to be in fixed update because it's not physics, it's sprite animation based. So what we can do in update is try to get the correct current clip from the directional animation set. So I'm going to do underscore current set dot get, let's say, facing clip. And we need to tell it what direction we're facing. So for right now, I use axis input directly. And then this is going to give us a animation clip. And I could call this the expected clip, what we expect the animator to be playing. So let's create this function inside of the directional animation set. So I'm going to hit Control period here, generate method, and let's go over to directional animation set. So this has been automatically created. I'm going to change internal to public. So the two things we're going to need to do here is to get the closest direction to the input. And I'm also going to rename this parameter. We're going to say facing, since we're not necessarily taking the raw input, but rather we're taking the direction that we expect to be facing and turning that into an animation clip. So we're going to get the closest direction to the input. And once we have that, we are going to return the animation clip based on closest direction. So to get the closest direction, we're going to want to create another function for that. It's going to return a vector2. I'll call it get closest direction. This is going to take a vector2. I'll call it input direction, I guess. Okay, so we might expect that it would generally be normalized before we return it, but we want to make sure that the direction doesn't have a magnitude associated with it, and based on its up, left, right, down directions, that we return it to a magnitude of 1 to normalize the vector. So let's do vector2 normalized direction is going to be input direction dot normalized. And how I'm going to do this is we're going to take the input direction and compare it to each of these 4 directions, up, down, left, right, represented as a vector2. Check the distance between the normalized direction and those directions, and whichever one has the least distance is going to be returned as the actual final facing direction. So we're going to need the vector2 closest direction. So this is going to store so far what has been the closest direction, and I guess we can default that to vector2 0 by default since we haven't compared it to anything. So we're going to need to start with having the closest direction so far, and then we can have a float for the closest distance as something we just cache once, and then we check if the new distance for the thing we're comparing to is less than or greater than the last one. So that can also just be there. Next up, I want an array of vectors that we're going to check. So up, left, right, down is the contents of that array. So we need a new vector2 array with 4 positions, and I'll call this directions to check. And this will be a new vector2 array with size of 4. And now let's create the contents, and that is going to be vector2.up, vector2.down, vector2.left, and vector2.right. If you needed to do, let's say, 8 directions or something, you could always have more directions to check, and then you could account for stuff like up, left, and up, right. But we're just doing 4 directional animations for our game here, so that's all we need. Okay, so right here at that part, we don't need the 4 there. The 4 goes here when we actually initialize that array. Okay, so now we need to loop through all the directions and just figure out which one is the closest. So let's do a for loop. Int I equals 0, so I is index, and then I is less than directions to check dot length, and I auto increments with ++ every time we go through this for loop. So for the first one, we want to automatically assign it to be the closest one because we haven't checked anything yet. So I'll just have a quick boolean here. First set, bool first set is equal to false. So if first set is not true, so got to put the exclamation point there at the start there. So if the first set is not set to true, then we're just going to take this and make it the first one. So closest direction equals directions to check I. And then we just need to get the distance between the input direction and, in this case, it will be vector up, but it could be whichever one you check first. So the one we're checking. So to do that, it's pretty straightforward. Let's set the closest distance to vector2.distance, and then we just put in 2 vectors. So let's see, we want input direction, and then we want, as the second vector, directions to check I. Okay, so that's how we get the first one set. It's going to happen automatically. Don't need to do any extra checks. Otherwise, we compare to the current closest direction and distance. Okay, so the rest is pretty straightforward. We just check the distance between the input direction and each of the other directions to check. So let's get a new float in here. So I'll call it next distance, and this is going to be equal to vector2.distance between input direction and directions to check I. And remember, every time we go through this loop, I is auto incrementing. So the second time is going to be down, and then it'll just check left, and then it'll check right. Okay, now that we have the distance, we just need to check if the next distance is less than the closest distance. So if that's true, then closest distance equals next distance. So if it gets in here, then we have a closer vector found. And if that's the case, then we also want to set the closest direction to be equal to the one we're currently checking. So that's directions to check I. And I guess we're getting a little error here, use of unassigned variable. So I suppose we'll have to initialize the closest distance with 0f as a value. As long as we have this first set check, that shouldn't be a problem, since in here we're going to set the real values for those to be compared. Oh, also something I forgot, got to make sure that first set gets set to true after this one. So first set equals true. If we forget to do that, then it's always going to be just going in here and automatically setting whatever here as the closest distance without doing a real check. Okay, so we have the closest direction set if it is actually closer than the last one. And we also set the closest distance, so that's all good. Now we just need to exit this for loop when we're all done and return the closest direction. Okay, and that is giving us a error as well. Has to unassigned local variable. Okay, so I guess we'll initialize this to vector2.0. Should only really be a problem if we fail to come in here to this bit, but that's why we're having this Boolean check. So that should be fine. Okay, so we return the closest direction after everything is found. And with that closest direction as a cardinal direction, up, down, left, right, we can come back up here to the getFacingClip function. And we'll use that direction to determine whether we show up, down, left, right as the animation clip. So vector2, and this is going to be closest direction equals get closest direction based on the facing direction. Okay, and then let's just do like a switch statement here. I think you can do a switch statement like this. We'll find out. So a switch on the closest direction. So we're checking what the closest direction is, and then we'll have different cases. So because vector2, up, down, left, right are predefined vectors, I think this should work, but we'll see. So in the case that it is vector2.down, we'll do something. Let's see if we get a error message. So you can't use the switch statements on vectors like that, I forgot. So instead we'll do a if-else statement. Okay, so if the closest direction is equal to not vector2.0, but vector2.left, then we'll do something. Else if, and don't forget the else, that's important. We'll check if it's vector2.right, then we'll do something else if, let's see, closest direction equals vector2.up. Okay, then we're going to do something. And then lastly, else if closest direction equals vector2.down is what we're missing here. Then we'll do something. And I also want to just put in one more else at the end as like a error issue, which is that the expected value is none of what we actually thought we would get there. So we can throw some kind of error message. You could either use debug log error, which will just automatically log something to the console, or you could throw it as an exception. So something like throw new argument exception. Then as the message, we could say something like $, quotations, direction not expected. And the reason for the $sign is so that you can do this, squiggly brackets, and then closest direction as a value, and end the parentheses. So basically, this part will just take the actual values and automatically insert it into the string. So you don't need to concatenate your strings together to form a final one. You can just kind of include the values as part of the string. Pretty handy. Okay, anyway, let's actually figure out what we're going to do based on left, right, up, down. So this should be pretty obvious. We're going to return the clip based on if it's left, right, up, or down. So let's return, let's see, left. And then for right, we'll return right. For up, we're going to return up. And for down, we will return down. Okay, so what we've effectively kind of done here is created the logic for a blend tree without having to blend the properties and the animator clip together as we move between our directions of left, right, up, or down. Instead, it's just going to be returning the animation clip exactly as we keyframe it, and then we just do animator.play to play that clip directly. No actual blending between the animations whatsoever, which is what we want for our purposes. So I'll just kind of put this up here for another second for you guys. This is probably the most complicated code we're going to write for this series. So let's go ahead and add a summary. Okay, so get closest direction based on a normalized input direction. Return the vector to direction in the list of directions to check that is closest to the input direction by comparing the distance between the input and all direction vector 2's in the list. Hopefully that makes sense. Okay, so this one up here, and by the way, if you want to know how to like quickly add these in Visual Studio, if you just do 3 forward slashes, it'll automatically fill part of this in so that you can just describe what a function actually does and how it works. But for the get facing clip, after comparing the expected facing direction to the direction options, return the animation clip that most closely matches the input facing direction. Hopefully that's pretty straightforward for you guys. After we get the closest direction, we just use that to pick the animation clip. And if for some reason none of these actually match a valid clip, then we'll have a argument exception. Okay, so now that all that hard work is done, we can go to the player controller and let's see, in update, we're going to get the facing clip and we're going to set that to the expected clip. So I think what we can do here is just check that the current clip isn't already the facing clip, because if it is, that doesn't make much sense to tell it to play again. So what we'll do is that whenever we set a clip, we'll have a private animation clip, current clip here as well. So if, let's say, current clip is null, or current clip does not equal the expected clip, then we're going to tell the animator to play the expected clip. So animator, and I think I made that underscore animator as a private class variable. And we'll do equals, oh sorry, animator.play expected clip. We do need to give it a dot name here though. So let's see, animation clip has a name, and that's the animation we're going to play. Okay, so one little gotcha of doing animator play like this is that the state, the animation state inside of the animator has to have the same name as the clip. So if we go back to Unity now and we check animator, you'll see that there are these 4, you could think of them like animation states. So right now they all have the same names as our animation. When we tell it to play one of these, it's going to be playing the states automatically here. So instead of doing right-click make transition to these states as you normally would with a standard blend tree, our logic is actually just inside of our player controller script now. So just something to be aware of if you're trying to play a clip and it doesn't exist in here in your animator controller, then you could run into a bit of an issue there. But this should work basically fine in general. So this is one of the things that the Animator plugin was kind of trying to fix, I think, making it so that you're not reliant at all on having an animator controller. But for our purposes, it should be plenty okay like this. So let's see, we have the idle animation. Actually, let's just go ahead and hit play. It might already work. Let's hit play. Okay, up, down, left, right. Okay, so it's kind of working. If we put down, then we face down, right faces right, left faces left, and up faces, yeah. Okay, so I know exactly what's going on here. It's that when the input is 0, we're still setting the input, and then it's automatically picking out our direction based on that. So let's hit play there. Let's go into the player controller script, and where we have on move, we want to have a facing direction that is separate from our axis input. So we only want to set the facing direction when the player's doing something like pressing a directional key that should actually change the direction the character's facing. So this will be a separate variable from the raw axis input. So we'll do underscore facing. You could just call it underscore facing or facing dir for direction. I think that's good. And we can set that to axis input. But we only want that to be the case if axis input does not equal, let's say, vector2.0. Then we can set the facing direction in here. Just got to make sure we make the private field. So generate the field up there at the top. And then when we are getting the facing clip, instead of using the axis input, let's use the facing direction. And that should fix our problem. So let's go to Unity. And we'll go ahead and hit play. Let's hit play. Up, down, left, right. Okay, as you can see, it's working great. So let's also hit play and play. Our default facing direction is, I guess, whatever's at the top of the list here. So if you want it to face down by default, then you can make that the first direction to check. So let's go into the script editor, directional animation set. And let's just swap the positions in this directions to check. So whatever's first is going to be the one that most closely matches vector 2.0, since it would all be in equal direction from here. So all we need to do to make it face down by default is do vector 2.down and then check vector 2.up. And then that should work just fine. So let's go back to Unity, click inside of here, hit play, and there you go. The character faces down by default because that's the first one to check in our script. And we can do left, right, up, down, and we have all of those animations.